Assalamualaikum and hi, I back to our lecturer Dr. Nur Hafizah. My name is Muhammad Nasrullah bin Muhammad Khir, and today I'm going to do a presentation regarding case study 6 in fluid mechanics. So as you can see here, he is a Swiss mathematician and physicist. Daniel Bernoulli was born 8 February 1700 and well known for Bernoulli's principle. So in this case study, I will divide into 5 chapters or 5 parts, which will start with introduction, engineering analysis, discussion, conclusion and recommendation, and the last one is reference. So the first part is introduction. This case study is about a farmer waiting for a tank to be filled with water that comes out from the faucet with flow rate 10 gallon per minute. How long the steady water flow will fill a 1.5 feet radius and 3 feet high tank. It is a cylindrical tank. So I will continue with engineering analysis for this case study. There are 3 parts in this section, which are theory, calculation, and the last one is analysis. So the first part is about theory. The volumetric flow rate can be defined by the limit Q is equal to V naught is equal to rate change of V divided by rate change of time T. V is a volume, Q and V naught is flow rate, volumetric flow rate. It is the same term. And then volumetric flow rate can also be defined as Q is equal to V times A. V is volume and A is area. So if we have mass flow rate, we can use the formula Q is equal to m dot per rho. M dot is mass flow rate and rho is density. Next one is calculation. So this is the calculation that I have done for this case study. It was given volumetric flow rate 10 gallon per minute, and then R radius 1.5 feet and height of the tank is 3 feet. So I use the formula of volume for cylindrical to calculate the volume of tank, which is pi r square h, and then I substitute the information given from the question into the formula, and then I'll get 21.21 feet cube. And then for the volumetric flow rate, I change the unit from 10 gallon per minute to 1.337 feet cube per minute. This action been taken to make the calculation easier, to make the next step of calculation easier. And then I use the formula of Q is equal to V per time, volume per time, and then I substitute all the information in this formula and I rearrange, and then I got time is 15.86 minute or 16 minutes. Next one is analysis. So this is the analysis that I come up from this case study from the calculation. The cross-sectional area of faucet is negligible as is stated from the question. Next is the total time needed to fill the empty tank is 15.86 meter. This information I get it from the calculation that I done before, and then as you can see here, this is the graph of water get in the tank versus the time taken. So it is a directly proportional graph, which is when the time increases and then the water that fill in the tank also increases. Alright, so the discussion part, I use the formula Q is equal to volume per time, and then I also did some unit changes, which I changed the unit of volumetric flow rate from gallon per minute to feet cube per minute in order to make the calculation easier. And then the last one is there is no pressure involved because we didn't calculate any sectional area. especially at the faucet part. And then what I can conclude for this case study, a steady water flow rate ensure a directly proportional graph. And then volumetric flow rate, also known as volume flow rate, rate of fluid flow, or volume velocity. It is a volume of fluid which passes per unit time. And then what is the recommendation that I can suggest for this case study? That farmer should repeat filling the tank at least 3 times to get a better result. And then the last one is reference. So this is the reference that I have made in order to complete this case study. I think that's all from me. Thank you.